Good day to one and all. Welcome to today's webinar on IT monitoring is no longer enough, get observability. My name is Shashidhar Reddy and I'm a product marketing manager at EG Innovations, and I'll be the moderator for this webinar today. Our speaker is Dr. Srinivas Ramanathan, the founder and CEO of EG Innovations. Srinivas, I think he has been working with IT monitoring and related technologies for over 25 plus years. And I think he has seen IT evolve from physical machines to virtual machines and then to cloud environments and probably now to containerized platforms. So without any further ado, let me pass the floor over to Srinivas to talk about the IT monitoring versus observability. Over to you, Srinivas.
Hey, thanks, Shashidhar. Hi, everyone. Here's the agenda for today's presentation. In case you're not aware about EG Innovations, I'll give you a quick overview of who we are. Then we'll get to the crux of our discussion today, which is how observability is different from IT monitoring. We'll delve into 9 key components that you need in an observability solution. And very briefly, I'll touch upon the EG Enterprise solution from EG Innovations and how it helps you get observability for modern IT. I'll answer a few questions towards the end of the webinar, but keep your questions flowing. So Shashidhar will pick the questions towards the end and we'll go through them. So just a quick intro to EG Innovations. We are a leading provider of enterprise class application and IT infrastructure performance management software. Our solutions are aimed at providing end-to-end visibility, helping with diagnosis, and giving you the reports and analytics you need to understand how well your IT environments, whether they are deployed on physical machines, virtual machines, cloud, or in a hybrid environment, are performing. EG Innovations has been in this business for the last 22 years. We're headquartered out of Singapore and have sales and support offices across the world. So the pins that you see on the map are the locations where EG Innovations is physically present. We also operate in about 52 different countries across the world through channel partners. We've been well known for our work over the years with IT operations and management. We were one of the first vendors supporting VMware technologies from a monitoring standpoint. We won the Best of VMworld award at VMworld 2008. We were one of Gartner's cool vendors in IT operations management in 2010. We've been well known for our work with emerging technologies like Citrix and BDI over the years. And recently, Software Reviews rated us as the best monitoring solution for application performance management across 14 different solutions that they surveyed. Over 1,000 plus marquee enterprise and service provider clients use our solutions. These are just some of our clients. Our client base spans various verticals. We have several insurance companies using our solutions, many retail brands using our solutions. Healthcare customers have also deployed our products for monitoring their mission critical environments. We also have clients across manufacturing, government, and several other verticals. Many service providers too use our solutions to offer managed services for their clients. We work closely with several leading IT vendors. Our solutions today are available on, we are a Microsoft co-sell ready partner. Our solution is also available on AWS Marketplace. Our solution is Citrix ready certified and Nutanix ready as well as VMware ready certified. We also work closely with SAP. Our solutions were certified by SAP for integration with their platforms as well. You can read up several customer reviews on different third-party sites that you can see at the bottom of your screen. There are very elaborate reviews of our products available if you're interested. With that quick background about EG Innovations, let's delve to the topic at hand, which is IT monitoring versus observability. Now, the moment I talk about IT monitoring, we've all been monitoring IT infrastructures for almost 25 plus 30 years. And the focus of IT monitoring has historically been on resources. How much of my CPU is being used? How much of memory is available? Am I using a lot of bandwidth? The monitoring has tended to focus on the key elements, physical elements of the infrastructure, servers, networks, storage, hardware, etc. And the goal of IT monitoring has always been to keep the resources available and the utilization levels as low as possible. Also, IT monitoring was deployed in infrastructures that were relatively static. If everything you had was physical, then there were very little changes going on. You had to physically move a server or move a system or an application in order to make it function from a different place. Also, most of the infrastructures that monitoring was deployed on were on premises. The first challenge with IT monitoring is the fact that today, IT is not measured by utilization of your servers. Your CIO, your CTO gets flustered when users complain of poor IT performance. So the metric that you need to be measured by is user experience, not IT utilization. So this is one of the first reasons why IT monitoring has had to evolve over the years. Talk to any enterprise organization today and you'll find that there is no dearth of monitoring tools. In fact, there are too many tools. There is one tool for the network, another tool for the hardware, yet another tool for the operating system, another one for the virtual platform, and so on. So from an IT manager standpoint, there are several tools that have to be looked into in order to understand how well is your infrastructure and applications working. The chart that I pulled up on my screen is from a survey that EG Innovations did with DevOps Institute. You can see the link to the survey. We surveyed about 600 plus IT professionals. And what we found when we asked them how many tools are they using was that 74% of our respondents were using at least 2 to 5 monitoring tools to track application performance. 17% were using more than 5 monitoring tools to get complete visibility. So there are too many tools in the enterprise, and often these tools are bought in a siloed manner. They're used by different administrators in the organization. So it's not as if one administrator, one central entity has access to all these tools. Your LAN administrator probably has access to the network monitoring tools. Your server admin has access to the operating system monitoring tools. Your virtualization admin is looking at the virtualization tools. And because each of these administrators is taking a different perspective and looking at a small subset of the overall infrastructure, when the user calls, the user doesn't call and say, I have a problem with a particular virtual machine. The user doesn't understand what infrastructure you have, whether it's cloud, virtual, etc. So the user complaint is always about a service that they're accessing. So the user complaint might be my web application is slow, or it could be that the Citrix desktop is not able to log in or log on is slow. So the user is always talking about the service or the application that they're accessing. From an IT perspective, this has to be translated into actionable event at one of the different tiers. Now, the IT help desk or the service manager who's responsible for the entire service and is reporting back to the executives has a big challenge at hand because he or she doesn't have access to tools. All the tools are with the IT admins. Each of your admins has a limited view of the overall infrastructure and uses different tool sets. Therefore, IT troubleshooting has been very difficult and very time-consuming over the years. Now, if you look at what happens when IT problems happen, this directly translates into business loss or cost. Imagine a scenario where users are working from home, they're connecting in, you have about 5,000 users connecting in, and your application is slow for about 3 hours. If the average cost per user is about $200 per hour, and if you have 3 hours of downtime, a single incident can cost your organization up to $300,000 in lost business. At the same time, your IT team is spending those 3 hours trying to troubleshoot a problem. And if you have 10 of your IT admins working on that problem and assuming the same cost per hour, you're spending almost $6,000 of IT cost every hour per incident. If you have 10 such incidents in a year, you can imagine the overall business cost or loss. So again, we going back to our APM survey, we asked IT professionals to rate how well their help desk was able to troubleshoot problems. And we found that 68% of respondents told us that the help desk was not very productive. Almost half the time, the problem was sent to the experts, not tackled by the help desk. In an ideal situation, you want the help desk to triage problems correctly, to send it to the right expert. And what we found from the survey was 68% of the time, IT help desks were not able to triage problems correctly and send it to the right expert. So these are some of the challenges that we're facing with IT monitoring today. Now, when you look at what modern IT operations needs to focus on, clearly the first point here is what I've spoken about before. IT needs to be aligned with the business goals. User experience must remain good for your users. All your key business processes need to work. IT is not measured by utilization levels. Couple of other changes have emerged in the last 3-4 years, and those are the bottom 2 points that I've listed here. First and foremost, there are a number of modern IT technologies that have evolved. IT teams need to look at these technologies and make sure that they can support them. Secondly, IT operations, the way we do IT support, IT management, has to evolve with the needs of the organization. And I'll touch on these 2 points in my next slide. So let's compare how traditional IT used to be and how modern IT has evolved. Traditional IT used to be predominantly work from the office. Modern IT these days is about hybrid work styles. Either you work, some portion of your workforce works from the office, some portion remote, and there have been situations in the recent past where majority of your users have had to work from home. As a result of this, physical meetings have given way to virtual meetings using Teams and Zoom and other tools. Corporate desktops have been replaced by bring your own devices, sometimes even bring your own bandwidth. So from a troubleshooting perspective, IT teams have had to troubleshoot issues that they've never had to deal with before. User connecting from home saying it's slow, is the issue really in your home network or could it be in your corporate network? IT infrastructures are changing. More and more organizations are starting to move workloads to the cloud. N-tier applications are giving way to microservices and containerized applications. And what used to be commercial off-the-shelf applications are being SaaSified these days. Even something like SAP is being moved to the cloud and being accessed from the cloud. So that is from an IT infrastructure and application standpoint. From an IT operation standpoint too, there have been remarkable changes. We've begun to understand that we can't rely on experts. What if your expert falls sick, is out for a couple of months, then you're in trouble. So you need to set in place processes and tools that can be used by anybody in your organization, not just by your experts. And ease of use becomes important. You need to focus beyond IT resources on user experience and business results. The focus is on minimizing. Again, we cannot rely on having a large staff available all the time. And many organizations are being asked to do more with less. So DevOps is becoming a practice that is being widely adopted. And the overall goal is to automate the manual and repetitive tasks. IT needs to move away from being reactive to being proactive. And the focus needs to shift beyond availability to look at performance. And as I'll cover later on, even security and cost control. Now, finally, we've had situations where even IT administrators can't work from the office. And therefore, whatever tools you need to adopt need to be accessible from anywhere at any time. So what is observability and how different is it from monitoring? Now, Gartner, the analyst firm, in their recent application performance monitoring Magic Quadrant report, used the term modern monitoring to refer to observability. So observability, as you can see from the synonym, is not dramatically new. It's essentially taking what we did with monitoring and making it better. So how do you make it better? So monitoring used to focus on systems. Observability tends to focus on what is important for the business, which is users. Monitoring was more focused on telling me when something was wrong. Observability tends to focus on the why. It's not enough to know it's wrong. I need to fix it quickly, so I need to know why it's not working. Monitoring was about finding when there is a problem and responding to it. Observability is being ahead of the curve, being proactive so you know about problems before your users notice and complain. Monitoring tended to focus on quick response. Observability tends to focus on reducing the duration and impact of incidents so business cost and loss is minimized. So as I said, the takeaway from here is observability is not something dramatically new. It's taking monitoring, making it better. Think of it as modern monitoring. Now, observability doesn't happen by itself. You need to, here are the main elements, the 9 main elements of an observability strategy that I'm going to talk about. The core of observability remains monitoring. If you don't monitor, you can't observe. But just monitoring is not enough. You need to take the metrics from monitoring and make sure you have the right monitoring. Use the monitoring metrics to provide interesting details for different stakeholders in an organization. One big difference between observability and monitoring is who uses the tool sets. Monitoring was essentially used by the IT admin, system admin, network admin, IT engineer, etc. Observability has different stakeholders. An example of it is your finance guys. Cost control, as you move to the cloud, costs become a big issue. IT admins never had to talk about cost in the past. When you're in the cloud, you give a report of your charge from the cloud provider. Your finance team is coming after you to say, why did my cost increase? So the stakeholder for observability is not just the IT admin, it's the other people in your organization who have to collaborate with you and support the business. So that is one big shift between IT monitoring and observability. So let's now talk about the 9 core areas of observability. But before we get there, whatever you frame as your observability strategy must address the core areas of modern IT. I told you that IT has changed. There are so many new technologies being deployed. Your observability solution must understand how to monitor digital workspaces because those are being used to support users connecting to your corporate network. You're deploying different kinds of applications. It's no longer sufficient to monitor systems. You need application level visibility, and that is where APM comes in. The core of your environment is often the enterprise applications and sometimes even SaaS services like Office 365 that are being widely used. And so monitoring those core business applications and services is important. At the same time, you need end-to-end visibility because if you have gaps in terms of what you can monitor and observe, then you're not going to be able to troubleshoot issues. So getting that single pane of glass view is also an important core area of focus for observability. So observability as part of IT operations must be aligned with DevOps processes because that is where organizations are moving towards. The automation of routine IT practices must be facilitated by our observability strategy. Security has become very important. The focus of observability cannot be availability alone. In fact, it shouldn't be just performance either. It has to focus beyond availability and performance and must cover aspects of security and cloud cost control. At the same time, the users of observability solutions may not be IT experts. I gave you the example of your finance guy wanting to understand cloud costs. Your help desk may want to use observability tools well. So the tool must be simple to use. Non-experts must use the tool. Where possible, it must be integrated with IT workflows, must be scalable and accessible from anywhere at any time. So let's start by going into the 9 key components of an observability solution. I'll start with metrics collection, and I'll spend quite a bit of time on this because it is extremely important that you collect the right metrics. Otherwise, it becomes a question of garbage in, garbage out. The metrics that you need to collect need to be domain specific. I'll take the example of I'll take a medical analogy to help you understand why the metrics matter. Now, consider a diabetologist. The type of metrics that they're looking at to understand if you're doing well or not are very different from the type of metrics that an ophthalmologist is going to be looking for when they check your eye. At the same time, this could be very different from what your cardiologist is looking at. So clearly, different physicians, different doctors are looking for different types of metrics. In the IT world, the metrics you need to collect vary depending on the technology you're looking to monitor. So whether it's you're monitoring a database, a virtualization platform, a network infrastructure, the metrics need to be very different. Very often, built-in vendor instrumentation is insufficient. Main reason for that is the vendor is not looking at it from a manageability perspective. Their focus is to make their database as fast as possible, their virtualization platform as functional as possible. They are not really looking at it from a monitoring and management standpoint, and that is why metrics from the built-in vendor instrumentation are often insufficient. The types of metrics that you need can be determined based on vendor best practices. So often consulting organizations within a vendor put out a material that talk about how to, from their experiences deploying their software or hardware, on how to best monitor their environments. Those are great places to understand what metrics you need. These days, there are many communities out there, community forums, good places to get feedback from. Experts give you write blogs that can be good sources for what inputs you need to have from what metrics you need to collect. Metrics may also be based on use cases. For example, when the pandemic happened, a lot of organizations started asking us to report on active times for a user connecting from home. Is he or she logged in for 8 hours a day? Are they active? How long are they active for? So those types of metrics became important depending on the use case that the organization had. But the point I want you to take away is that every agent is not the same. There is a tendency in the IT world to think, if I got an agent from every vendor, they're all going to collect the same metrics. That's really not the case. The level of detail, the type of metrics, and the ability, the depth of metrics really matter. Now, whenever we talk about metric collection, a common point that comes up is your tool agent-based or agentless? In my perspective, this is really not a discussion point anymore. There is clear understanding that if you want to monitor your network devices, firewalls, load balancers, storage, you can't really deploy agents, so you have to be agentless. If you want to get insights from your cloud accounts, there is no place you can install an agent from, so that is also agentless. Monitoring of your virtualization platform, VMware, Nutanix, etc., have very strong APIs, and so those can also be monitored agentless. Now, your legacy operating systems, Windows, Linux, etc., if you have key applications on them, you need to look at agents. There are three reasons why I say this. First is security considerations. Agentless is not free. You have to open ports. Anytime you open a port, you don't know who's coming into that server to do anything. So it opens up a can of worms it's another potential point where an attacker could come in. Therefore, security concerns mean you don't want to expose unnecessary ports on your operating systems. The reason I said legacy server OS is because Windows, Linux don't have the type of APIs that modern environments, containers, cloud, virtualization expose. As a result, the overheads of monitoring, if you were to do it from remote, would actually be quite high. You would take up a lot more bandwidth. So from a scalability perspective, agent-based monitoring is preferred for these platforms. Also, if you have an agent on the system, you can go to a greater level of detail than possible from outside. Now, the second question that comes up is, how do you collect metrics? Do you use SNMP? The answer to this is, SNMP is no longer a standard when you talk about applications, virtualization, etc. And there isn't one API, one standard through which you can monitor your modern infrastructure. So you need your observability solution to be using any which way possible to collect metrics. So how to collect metrics is, in my opinion, a secondary question. What metrics you collect is the more important question. Now, if you had multiple methods giving you similar metrics, choose the method with the least overhead, but which gives you the key metrics that matter. So in a nutshell, my point is focus on what metrics you want to collect That is the key. Now, let's talk about what metrics you want to collect. User experience matters because that is the way in which IT is measured today. So if you want to be proactive, you want to be able to measure what your users are doing. And a key way of doing this is using synthetic monitoring. Synthetic monitoring means you're creating software robots that act like a user, access web pages or other types of non-web applications, and collect information about how long it takes to perform a certain set of mouse clicks. Now, this dashboard that you see on the screen gives you a workflow, a typical workflow that a robot is going through. It's accessing my homepage, it's signing in, it's selecting a plan, it's updating a service plan, and making sure that the update works, and then ultimately you're buying a plan and making a payment. Now, from the color codes, you can easily see when I make a payment, there is a problem. So if you had this kind of a dashboard available to you ahead of time, very quickly your help desk can figure out the issue is really not in my application or in my core workflow that I control. The issue is in my connection to the payment system. So I can direct the problem to the right expert or even to the third party. As you start using SaaS services more and more, the help desk may be able to call your SaaS provider, and therefore, rather than bring 7 or 8 of your experts into a call saying I'm having issues with the application, they could direct the problem to the right expert. Now, synthetic monitoring is great, and it's usually the easiest way to get started with, because you're deploying robots across your environment. You really don't have to put an agent on every single server out there. You can still glean insights into what users are seeing. Complementing synthetic monitoring is what I call as real user monitoring. Real user monitoring is focused on looking at what your real users are doing. There are many ways of collecting real user data. It depends on the type of application that you're monitoring. In this example, I'm showing you a dashboard from a web application. Using JavaScript injection, a common technology that is being used by many vendors, you can collect insights into where are my users coming from, which countries, which cities, what is the overall page load time looking like, are my users seeing JavaScript errors, what is the latency from different regions. So you can get good insights into where, again, what your users are seeing. Real user monitoring is important because synthetic monitoring probably looks at only a few workflows, probably uses the same set of logins to keep logging into your accounts. So in an ideal situation, you need to have both real user monitoring and synthetic monitoring deployed in your enterprise. Now, real user monitoring will change depending on the type of application that you've got. I showed you how JavaScript injection can give you geographic maps about performance and page load times. Now, if you were, this particular screenshot is taken from a Citrix deployment. The user experience metric of interest may even vary depending on the type of infrastructure and application that you use. When you log into Citrix, an important metric is actually logon time. How long does it take for a user from when they type their username and password to when they actually have access to a desktop? So you might, Citrix is a proprietary technology. Many other application technologies might be proprietary. You want your real user monitoring to use the APIs provided by the vendor or by the underlying operating system to get insights into where time, how long the logon time took, but you also get breakups of where that logon is taking time so that you can optimize how your user experience is looking like. While it's important to collect user experience data, from the same place, you also want to get as much insight as possible into how to troubleshoot a problem. In this example, you see that the logon time took about 48 seconds. If you focus on the details that I just brought up on the screen, you'll see that one particular client-side extension took 36 seconds. So clearly, if I were the Citrix administrator in this example, I would be focused on why this particular client-side extension is taking time. So real user monitoring doesn't just help understand the user experience, it gives you some level of insight into how to troubleshoot that user experience problem that comes up. Now, augmenting user experience is monitoring of usage. Sometimes your GPU taking time could be because your disk drive is just not doesn't have the right IOPS, isn't provisioned correctly, etc. So monitoring resources, CPU, memory, etc. becomes important, particularly in a case where you have a virtual machine or a cloud environment, because oftentimes when we deploy an application, you go to your IT admin and just give them some configuration. Now, how does the IT admin actually deploy it? Did they give you enough resources is often something we don't really know about. And therefore, monitoring the health of your underlying operating system, resources, etc., becomes very important. At the same time, it is important that you have early warning indicators of problems. CPU, memory, etc. may be good indicators, but often your clues come in other places. For example, if you're looking at a network, look at the buffer overruns on a router interface. If you are seeing an increase in buffer overruns, even if your application is not impacted today, it is likely to be impacted down the line. So start taking action now. Same way, look for packet errors on a server's network interface. On a virtual machine, CPU ready time is an important factor. It tells you how much time is this machine ready to run, but not getting CPU. That probably means you have an overcommitted environment. You don't have enough hardware resources to support the virtual server workload that you have. If you're in a cloud environment, look for things like IOPS. If you have an example, you could have purchased 20,000 IOPS from AWS for a database server. Are you using all those IOPS? If you're hitting close to capacity, it's possible that your application may come to a crunching halt when you exceed that limit. Same way, I'll give you an example later on, CPU credits on an EC2 instance. Cloud environments, very different. Up until the point in time where you use what is available to you, you will be fine. But the moment you go beyond a certain point, your application is going to stop and you will have huge performance issues. So early warning indicators are important metrics that you need to collect. I gave you the example of CPU credits, and here's a real world example that we were involved in. This particular virtual machine had been provisioned by a customer. The way CPU credits work, as your machine keeps running, you keep getting credits from your cloud service provider. When you start using credits, if your CPU utilization goes above 0, you start consuming credits. If you hit 100% utilization, credits are taken up very, very fast. So in this particular customer's case, they had a small burst where they took up CPU. Notice from the graph that the CPU credits are actually dropping down. And it reaches a point where your credit is almost 0. At that point, the virtual machine came to a crawling halt. Everything, the application was still running. Users were just not able to click on the application and do transactions. If you were looking inside the virtual machine, you wouldn't have been able to understand what happened. You have to have the cloud perspective in order to be able to troubleshoot this problem. So the point again is metrics matter. Make sure you have the right metrics in place. A concept I want to bring up is detailed diagnosis. Metrics by themselves will tell you you have a problem. In this example, I'm looking at disk activity. How busy is my disk drive compared over time? And you can see that there was a certain point in time where my disk drive became 100% busy. The question is not, it's good to know that your disk drive was 100% busy. Most important question is, why did it become 100% busy? The answer to that comes from detailed diagnosis, the ability to go in and collect additional details. So you want your metrics collection to give you additional details. In this case, the operating system is running a SQL database, seeing the details of what queries were being run at that point in time is extremely important, because that tells you if your application is not being designed correctly. The best time to capture the additional diagnosis is around the time when the problem occurs. So you don't want to wait for a human to come in and then run certain scripts to see what is wrong. You want to collect these additional details as we keep going, because it may not be possible to simulate issues down the line. APM is an important part of any observability strategy. The whole concept of application performance is being able to drill down into the application tiers to see what's going on. And APM, I'll talk about APM from a quick example. I brought up the EG Enterprise console where you're monitoring different elements in your environment. Notice that I'm monitoring 5 different WebLogic instances. WebLogic is a Java virtual application server. I'm going to click on one of the application servers and drill in. Now, what you're seeing is the EG Enterprise tool in action. We use the concept of a stack model to give you an idea of how each tier of your infrastructure is performing. While we look at the operating system, the TCP/IP stack, etc., most important is to look within the application tier and see what transactions are in flight. Here you can see many people have browsed the products catalog, but you see on the right-hand side that 100% of all transactions are slow. So why is it slow? I'll click on the magnifying glass, which is where we see problem diagnosis, and you'll see that a specific user, Ozella, accessed the URL, and it took almost 25 seconds for the URL to respond. Let me drill down further. Typically, for good performance, your execution time should be 4,000 to 8,000 milliseconds. Today, it's taking almost 25 seconds. Application performance monitoring allows you to drill into the code to understand how much time was spent in your application code, how much time was spent making external calls to other applications, how much time was spent making a message, putting a message into a message queue, issuing queries to your database, or even making third-party calls. Now, this particular concept of APM is called transaction tracing, and the idea is to tag every transaction when it comes into your first application and watch that transaction as it moves through tier by tier. Looking at the numbers, you can see in this case my database queries where my problem lies. Click on the database queries for more detail, and you can see the exact query that was taking time. So the concept of application performance monitoring is the ability to drill down deeper into your application and to understand where the problem lies in your application code. So APM is a very important part of any observability strategy, and APM essentially looks at the drill downs within the application code to spot application issues. Now, moving on from metrics collection, let me go into the other 8 components. I'll shift gears and move a little faster. User complaints almost always relate to a service, not a server. Therefore, IT operations cannot look at it from a silo-oriented perspective. They have to take a service-oriented perspective. To monitor a service, they need to know what are the tiers involved, how they interact with each other. A lot of this, anytime you ask a customer to give you a topology map of a service, they'll tell you they don't know. So auto discovery is an important piece of the puzzle. There are different types of dependencies that exist in IT environments today, and it's important to be able to look to discover those dependencies automatically. If I go back to my console, you'll notice that, so let me go back to my home page. What I mean as a silo-oriented view is what you see on the right-hand side. You can see your databases, your routers, your Active Directory, etc. A service-oriented view essentially means IT is looking at the problem from the user perspective. A user might call you and say, I've got a problem with easycart.com. You can drill down into easycart.com. We give you an idea of what the user experience is. I'm not going to go into this dashboard in more detail, but when I drill down from the user experience dashboard, you're going to see a topology map that shows how your service is laid out. You see the different elements that are involved in service delivery, what their interdependencies are. So you can see how many web servers are contributing to this service, which particular application servers are involved, etc. Discovering this level of detail and creating a service topology view is very important from an IT perspective so that you eliminate the amount of time that you're going to spend in terms of troubleshooting. Now, going back to my, we saw how service dependencies are important. The next problem that I'll talk, next element of an observability strategy is anomaly detection. This screen that I'm showing on the top part of this call is from one of our customer environments. Look at the total number of measurements that we are collecting in this environment. Runs into the millions, 217 million metrics being collected. If you're an IT admin and your job is to figure out which of these 217 million metrics is working and not, um, you're never going to have the time to manually sift through these metrics. So this is where machine learning comes in. You want your observability tool to not just take data and present it in a console, you want your tool to do the analysis. Here, we're showing you an example of what I call as auto baselining. The blue lines represent the actual data that we're collecting. Number of sessions to a server based on time of day. You see the 5 work days, and then you see the weekend where the number of sessions is lower. The yellow lines represent the auto-determined baseline. Notice that the auto-computed baseline it's based on past history, it's computed based on time of day, and therefore auto-computed baselines make it easy for you. You don't have to think about when there is there a problem or not. The observability tool is doing the work for you. So this is how you can be proactive, because your baseline is varying based on time of day, day of week, day of month, etc. Now, just applying machine learning alone may not be enough. You want to have sophisticated threshold definitions. Why do I say this? You could have a server that is completely idle for months, and then when one user logs in, suddenly it violates the norm, and you get an alert. Now, as an IT admin, you have to figure out, do I want an alert when one user logs into a server? And the answer is most probably not. So that is why we use a concept we call autostatic baselines, where you use machine learning, but you use human judgment as well to specify limits beyond which you care to be notified. So tell me only if there is violation of the automatic baselines and there are 15 users logged into a server, then I want to be notified. So you have flexibility. In an ideal threshold rule definition, you have flexibility to be notified. You want to be notified when your actual usage is twice the normal or 5 times the normal. Do you want to be notified when the first violation happens, or do you want to be notified after a certain number of violations happen? Observability is also associated with setting thresholds on multiple metrics. So when 3 of your 5 servers are down in a cluster configuration, only then alert me to a problem, or alert me based on average CPU of a set of servers, not based on a single server. So those are some of the capabilities that a typical observability solution will provide for you. So we looked at metric collection, service-oriented analysis, anomaly detection. Let's move to root cause analysis. This is probably the most important part of any observability strategy. Finding the root cause of a problem is like looking for a needle in a haystack. You have millions of metrics. When something goes wrong, there's probably only 1 or 2 places where things really went wrong, and that will ripple and impact all the other places in your environment. Therefore, finding the root cause often tends to be a challenge. Now, in the past, people used to use if-then-else rules. You used to have a rules engine. This is from a legacy monitoring tool used in the 90s, where you would create rules in order to be able to say where is a problem. Today, rules-based engines are not possible. Today's infrastructures are too complex. Microservices come and go. VMs migrate from one system to another. So you don't really have the time to create rules. So what you need is a rules-free correlation approach. There are multiple approaches like this. Predominantly, tools use 2 types of approaches. The first one looks at patterns, learns from patterns. So if problem A and B happened, then the root cause is C. The second approach is to use dependencies that exist in an infrastructure and to use those dependencies for correlation. Now, I'll give you a quick couple of examples about how root cause analysis works within our tool set, EG Enterprise. On my screen, I brought up a window where I'm looking at one particular web server. This web server is having a critical issue. Now, if you look at this stack diagram, you can see that there is a problem at the web server layer. I can't really reach the server. Availability is 0. I can't even get to its TCP port. But if I look at the network layer, I'll see here that I can't even ping the server. Packet loss to it is 100%. Now, in a typical scenario, both of these would have generated critical alerts. By looking at this stack diagram, the monitoring tool is smart enough to say, I've got a problem at a layer below that is more critical than a problem at a layer above. And therefore, it has downgraded the priority of the web server alert and is telling you that there is a problem at the network layer that you need to take action on. Now, that was an example of what I call as top-down correlation. Here is an example of something that is more sophisticated, that uses dependencies across application tiers. This service topology map we use not just to understand which tiers are working, which tiers are not. In fact, the color code gives me an idea of where my problems might lie. The bigger problem in this case is in the database tier. That is why it is orange in color while the others are yellow in color. So the monitoring tool has done some correlation in order to tell you where it thinks the real problem lies. Click on the database tier, and at this point, the monitoring tool is smart enough to tell you the database is running on a virtual machine that's hosted on a VMware server. The database server is hot, but the VMware server it's running on is actually hotter. So the real issue is not with the database server, but it's got to do with the VMware server. Now drill down into the VMware server, and you will be able to see the stack model of VMware that tells you where the real problem lies. So what's happened here is that one of my data stores in VMware has become almost 100% full from a space perspective. So there is no space available on the VMware server. The database server is seeing errors because there is no space available for it to write. In turn, this might actually impact the user experience. The user might see issues. Now, if you go to our alarms console and look at our incident management panel, you'll see that we have a number of alerts that are currently running right now. You see that your database is hot. You see that users are seeing higher average response time. You see that your VMware server is also impacted. Now, if you pick our new correlation view, our tool would have correlated all these alerts. And if you look at it, what we are really telling you is there are only two sets of independent alerts. There is a traffic manager alert, but look at the VMware alert. It's causing an issue at the Oracle database. The database is causing an issue. So if I click on the database, I see the other issues that are being caused by the issue in the database tier. So what we've shown here is how we use topology maps and different types of dependencies that we figured out. So we used application to application dependencies in the topology map. We used application to virtual machine dependencies when we went from the database to the VMware server. We correlated these dependencies in real time in software and helped you pinpoint where we think the real problems lie. So the advantage now is your help desk can call your VMware admin, doesn't have to talk to your application administrators. So that is how we help you reduce your mean time to repair. An observability solution should also help you. The expert might not want to just look at alerts. They may want to look at detailed insights. So the observability solution must facilitate manual correlation and analysis as well. So we have different types of slice and dice reports within our tool that allow you to compare performance metrics across different quadrants. I'm not going to go into the details of these reports, but if you're interested, there are reports available within the tool. If you look from a forecasting perspective too, an observability solution must look at the past, but it must also give you the ability to look at the future. So the ability in this example, the blue line represents your past history. The purple line represents what we forecasted as where you think you're going to be in the future. So this comes in handy from a planning perspective. Also important from a planning perspective is the ability to have capacity planning reports. Here I'm showing a report based on a digital workspace deployment where you can look at past history and say, what if my load increased? You have a slider, you increase the slide, move the slider to say how much is your session workload going to increase by. And based on that, we can tell you what increase you should expect in different resources on your servers and how many more servers do you need to accommodate to handle the increased load. So this is something that you can get from an observability solution as well. Another key component to the observability strategy is monitoring configurations. Many a times people focus on looking at performance. Often performance issues are caused by configuration changes. especially in new age deployments in containers, in cloud environments or virtual platforms, where it's very, very important, very, very easy to make configuration changes. Misconfigurations can have a huge impact on performance. And configuration errors are major cause of problems. So within the EG Enterprise Suite, the same agent that we use for monitoring configuration can also be used, for performance, can also be used for configuration changes. So here's an example of a problem that we encountered a few months ago. There were all of a sudden, a number of alerts relating to CPU usage of an application that was deployed by a customer. So we were wondering what the issue was, and the customer actually spent a lot of time to figure out, without being able to easily understand why there had been a sudden increase in CPU usage of the JVM. Now, cutting a long story short, this chart shows the configuration changes that happened during the time the problem happened. There were software changes, there were hot fixes deployed, there was an environment configuration change that we had tracked. And one of the changes that we found was one fine morning, we noticed the number of processors on the operating system had changed from 16 to 8. So the number of processors had dramatically been reduced. What the customer also saw was the number of processors hadn't changed in the cloud configuration. So their AWS configuration still showed 16 processors. However, something had changed within the Windows operating system, possibly because one of the hot fixes were deployed that caused the number of processors to go down at the operating system level. So the increase in CPU, the CPU alerts that we were getting, was not because the application performance had suffered, but it was because the machine had suddenly gone from a 16 processor machine to an 8 processor machine. And so utilization levels all of a sudden became much higher. So this is an example of where you can't just limit yourself to performance changes. You also want to look at configuration changes. More and more these days, observability also has to encompass security, because there are changes. If you have an agent on a system, you have the ability to look for simple checks within that environment that can give you early warning indicators of potential problems. So for example, looking at the Windows services on a Windows operating system to see if those services may have vulnerable permissions. So an attacker, if they get into your system, if they can copy over files being used by a vulnerable service, they can actually take over your system. So detecting those kind of situations, or even new files that are being created in privileged folders like a root folder, are often indicators that your system is under attack or somebody else is doing something that they should not be on your system. So having the ability to do that within your solution is an important component of an observability strategy. We spoke about capacity planning, almost as important as cost control. Especially in the cloud, you could use up money in no time. And having the ability to track your costs is important. Having the ability to make sure that you can fine-tune your deployment, to right size it, to make sure you're just spending the right amount of money, is becoming vital. So in an observability solution, you will be able to clearly see which systems are overutilized, which ones are underutilized. The underutilized systems are often targets for right sizing. Same way, there are also reports, many tools today that give you right sizing reports that tell you whether a virtual machine is undersized or oversized. Having that type of capability is important, again, to ensure that your cloud costs are optimized. More and more, I think there is also observability is also focusing on reducing the routine work that an IT admin has to do. Automation is an important thing for you to consider. Generic automation in production is very difficult, but you can look at automation for well-defined problems. So if you know that a particular service that needs to be running has stopped, then automation can help you restart it. If you know that you're running into situations where Windows updates, when they fail, are taking up a lot of space, you might want to have automation to check if your disk drive is becoming full because of an update failure. And if it is, you can clean up the update. Same way, when a user connects to a digital workspace, If they disconnect instead of logging out, they could be using up resources. So if you want to save on resources, get better value for money, you might want to periodically check your systems and see, has anybody remained disconnected for over 30 minutes? And if they are, you can log out that session automatically, thereby saving resources. So look for ways in which you can add automation into your observability framework so you can make your IT operations processes very more efficient. So summarizing here the 9 key elements of what I believe an observability strategy needs to employ. Metric collection is important. You need to take a service-oriented view, not a silo-oriented view. Look for the ability to do root cause analysis as automatically as possible. Find ways to track configuration changes along with performance. Look for the ways to right-size your environment and save on cloud costs. The EG Enterprise solution from EG Innovations incorporates many of the capabilities that I've outlined here from an observability standpoint. I'm not going to say that we've cracked the observability problem completely. There are several areas where we are still exploring ways to make our solution more intelligent and more effective for clients. So you will see additional capabilities roll out as we go through the year and bring out new versions of our solutions. Since different customer environments may have different types of infrastructures, within our tool set, we've built wide-ranging platform support. The logos that you see on the screen are just examples of the different technologies we support. A full set of supported technologies is available on our website, eginnovations.com. And at EG Innovations, we focused on ensuring that we cover the main areas of modern IT, because many customers, as they deploy newer technologies in the field, don't have the expertise in-house to handle these technologies well. So a lot of our emphasis as we look at observability have been around these four core focus areas of modern IT. I want to end by just saying that tools themselves are not sufficient. So if you just had the best monitoring tool in place, that would not help you become efficient. You need to make sure that you've wrapped around the tools people and processes. So you need the right people with the right expertise, but you also have to make sure that you have put the processes in place to align with the best tools and the best people to ensure that your IT operations becomes effective. So please do not underestimate the value of people and processes. Tools by themselves will not give you the results that you're seeking. In an ideal world, you want all three to be well aligned to deliver the best results. I want to end here by just saying that EG Enterprise is available today as a free trial. It takes less than 15 minutes to set up a trial of our solutions. You can test drive our solutions for any of the use cases that I mentioned before. And here's the URL for testing out our solution. With this, I want to hand the floor over to Shashidhar for any question and answers.